Hello Math 130 students. We will pick up on page 11, section 5.5, solving rational equations. So I made sure to space out my work or space out the problems so that I can show all of my work. So here are some guides or some steps to solve our rational equations. So step number 1, we want to determine the least common denominator. So if I'm trying to figure out my least common denominator, then I am going to look at the denominator of each fraction. So it's already simplified as possible. I don't need to factor any further. So it looks like I have a 4v and also have a 3v minus 2 in my denominator. So for that first fraction, I'm going to have a 5, 3v minus 2. And remember, our step number 2 is to multiply each fraction by the missing LCD in numerator and keep the denominator factored. So here, that missing term here is a 4v that I'm missing from my LCD. So I need to multiply the denominator and the numerator by what's missing. And this is equal to my 7 times my 4v. Now that 4v from the denominator, it's missing a 3v minus 2. So then from here, I'm going to look at this and I am going to do step number 3, which is to combine like terms in the numerator. So you're going to leave the denominator alone, but you're going to combine like terms in the numerator. So you're going to have a 20v over 4v, 3v minus 2 is equal to a 21v minus 14 over 4v, 3v minus 2. Now for step number 4, we are going to solve the equation. So if I'm solving this equation, I have two fractions that are equal to each other, which is really nice. So you can actually say that 20v is equal to 21v minus 14 because the denominators are the same. And you might be wondering why, well, how do you know that? Well, because if I were to multiply both sides by 4v, 3v minus 2, it actually cancels the denominators out. So that's a really cool fact that we have about these fractions, that once you cancel them out, then you're just left with your numerators. So now what I'm going to do is I'm going to subtract 21v from both sides. So if I have 20 minus my 21v, I have a negative 1v equal to a negative 14. And here I'm going to divide by negative 1 on both sides. So that v is equal to a positive 14. So for step number 5, you want to make sure that the solution doesn't contradict. So do I have any restrictions in my domain? Does this make it true? Well, if I have v is equal to 14, well, let's plug it into my equation. I have 5 over 3v minus 2 is equal to 7 over 4 times my v value. And that v value that I'm plugging in is 14. So when I get my calculator, I will have 5 over, if I have 3 times 14 minus 2, that gives me a 40. So if I have 4 times 14, that gives me 56. So if I do this on my calculator, 5 divided by 40, that gives me 0.125. Is that the same as 7 divided by 56? It's a 0.125. So what I just did was I checked the solution. So I have checked it, and I know for a fact that v is equal to 14 is going to be the solution to this first example. Okay? All right. So now let's look at number 2. So it looks like the denominators are as factored as possible. So I'm going to have my LCD as a q minus 2 and a q plus 4. And remember, this denominator on 1, it really is a 1. So now I'm going to rewrite it. I have a negative 10 over q minus 2. So what's missing from this denominator is a q plus 4. So I need to multiply bottom and top by what's missing. And I have a subtraction. Now I have a 7 and I have a q plus 4. So what's missing from this denominator from my LCD would be a q minus 2. So I need to multiply both the denominator and the numerator by what is missing. And I also have a 1 over 1. So what's missing here is everything. So I need a q minus 2 and a q plus 4. So all of that is missing. So now in my step number 2, I'm going to distribute. So I have a negative 10q minus 40. And here I'm going to take a negative 7 that's going to be multiplied. So a negative 7q plus 14. And it's equal to, and here I'm going to go ahead and FOIL. So my first is q squared. My outer is a positive 4q. My inner is a negative 2q. And my last would be a negative 8. And again, because the denominators are all the same, and only if they're the same, then you can drop them. It's as if I were to multiply each one by the LCD, right? So just like we did in example number 1. So this is what I'm really left with. So now I'm going to clean this up a little bit. So I'm going to combine like terms. Or actually, you know what? I'm going to rewrite this. So I have a negative 10q minus 7q minus 40 plus 14 is equal to my q squared plus 4q minus 2q minus 8. So if I'm going to add my negative 10 and my negative 7, I'm going to get a negative 17q. And if I add my negative 40 plus 14, I'm going to get a negative 26. And that's equal to my q squared plus 2q, because I added 4q minus 2q together, and I have my minus 8. So now from here, I'm going to solve for my q. So I'm going to add 17q. And I'm going to add 26 to both sides as well. So then on this side, I get a 0. Perfect. I have my q squared. And 17 plus 2 is going to give me a positive 19q. And negative 8 plus 26 is going to give me a positive 18. So if I were to do the AC method and rewrite my middle terms, well, I would get that A times C is a positive 18. I get a positive 19. So here, 18 and 1, if they're both positive, will give you a positive 19 and adds up to, it adds up to a positive 19 and multiplies to a positive 18. And because the leading coefficient here is 1, then I know exactly how this is going to factor. I have my q plus 18, and I have my q plus 1. So now, setting each thing equal to 0, q plus 18 is equal to 0, so that q is equal to a negative 18. Q plus 1 is equal to 0, so that q is equal to a negative 1. And you always just want to make sure that nothing is going to give you a 0 in the denominator. If I plug in a negative 18, it checks out. If I plug in a negative 1, that checks out as well. Okay, so that is going to be my final answer. Q is equal to negative 18 and Q is equal to negative 1. Now let's look at number 3. Here, if you need to, you can write the 1 underneath the 4. And I also see that this d squared minus 9, that factors as a difference of squares. So that would be d plus 3 and d minus 3. So my LCD actually becomes d plus 3 and d minus my 3. So you're going to multiply by what is missing. So if I have my d and I have my d plus 3, well, what's missing here would be my d minus my 3. So I multiply top and bottom by what is missing. I have an equals, I have an 18, and remember I had d plus 3 and a d minus 3. So nothing is missing there, which is really nice. Plus 4, and what's missing here, because it's a 1, I'm missing everything. So I need my d plus 3 and d minus 3. So I'm going to write that in red. So now, because all of my denominators are now the same, I'm only going to focus in my numerators. So I'm going to distribute to give me d squared minus 3d is equal to 18 plus 4. And here, if I were to FOIL this out, I would get d squared minus 3d plus 3d minus 9, which your two middle terms, your outer and your inner, that negative 3d and that positive 3d cancels out. So now you're left with a d squared minus 3d is equal to 18 plus 4, d squared minus 9. So I'm going to distribute that positive 4. So I have a 4d squared, and 4 times negative 9 is going to give me a negative 36. So from here, I'm going to subtract a d squared from both sides, and I'm going to add 3d from both sides as well. So everything can cancel here. So I'm left with an 18 plus 3d squared minus 36 plus 3d. So what I want to do here is add the 18 and the negative 36 together. So I have 3d squared plus 3d, and 18 minus 36 is going to give me a negative 18. Well, when I factor here, I can definitely see that my greatest common factor is a 3. So I'm left with a d squared plus d, and 18 divided by 3 is a positive 6. So if I'm looking at this, if you want to do the AC method, that's fine. Some people like it. So it looks like the leading coefficient is 1, and my C is a negative 6, so I have a negative 6 and a positive 1. So I'm going to say that's a 2 and a 3, positive 3 minus 2. Because 3 minus 2 is 1, and negative 2 times 3 is a negative 6. So now I have that 0 is equal to 3 times my d minus 2 and my d plus 3. So now I'm going to set each thing equal to 0 by the ZPP rule. So 3 is equal to 0, d minus 2 is equal to 0, and d plus 3 is equal to 0. Well, 3 minus 0, that doesn't make sense. But in the second one, I'm going to add 2 so that d is equal to 2. And in this one, I'm going to subtract 3 so that d is equal to a positive 3. Now, this is where you want to be careful. Remember that your LCD was a d plus 3 and a d minus 3. What happens when you plug in a negative 3 into here? Well, if you let d equal to negative 3, let's think about this. So let d equal to a negative 3. So if I have d plus 3 and d minus 3, well, I have negative 3 plus 3 and negative 3 minus 3. Well, this would be 0, right, times my negative 6, which would give me a 0. So this tells you that your denominator is going to equal to 0 whenever you let that d equal to 3. But what happens whenever I have some number, let's say 5 divided by 0? That would be my undefined. So this is not good. Because it is not a good answer, we're going to throw out that x is equal to negative 3. The only answer that's going to work is that d is equal to a positive 2. When I plug in a positive 2, it does not give me a 0 in the denominator. So this is the only answer for number 3. We have 3 possible answers, right? D is equal to negative 3, D is equal to 2, and 3 is equal to 0. So the only answer that makes sense is D is equal to 2 for your final answer. So you always want to make sure in that last step, verify your solutions by plugging it in, okay? All right, so now let's look at number 4. So on number 4, we are going to have to do some factoring, which is fine. So let's take a look at this first fraction. So I have an x, and if I were to factor the denominator, I would have a 3, now I have an x minus a 3. If I'm going to be looking at the second fraction, it looks like it can be a 3 up on top, and my GCF on the bottom is a 4, so I would have an x plus a 3. And I have my equals. Now I'm going to look at this last fraction. So I know I'm not going to be able to do much with the numerator, so 7x squared plus 6x plus my 63. So I'm going to look at the denominator over to the side over here, my scratch work. So I have 24x squared minus 216. I know that my GCF here is a 24, so that I have x squared minus a 9. But I know that can be written as a difference of squares, so I have an x plus 3 and an x minus a 3. So I just factored out that purple fraction over to the side, and I have my denominator factored as possible as 24 x plus 3 and x minus 3. So now I can clearly see what my LCD is going to be. My LCD, well, look at the numbers, 3, 4, and 24. 3 goes into 24, 4 goes into 24, so my LCD is going to have a 24. I also have an x plus 3, and I also have an x minus a 3. So if I'm going to be looking at that first fraction, I have an x, and I have a 3x minus a 3. So what's missing here, well, 24 divided by 3 is going to give me a positive 8. And I'm also missing my x plus 3. Okay. Then I have my minus, and I'm going to have my green fraction. So 4 over x plus 3, and 3 in my numerator. So what's missing here, if I have 24 divided by 4, that's going to be a 6 that I need to multiply by. And I'm also missing the x minus 3 as well. And my purple fraction, I don't have to do anything with it. It's already factored as possible. So 7x squared plus 6x plus 63, and I have my 24 x plus 3, x minus 3. Because that denominator happened to be the LCD, I didn't need to multiply top and bottom by anything. So now I'm just going to simplify this a bit further. So I have my 8x, that's going to get multiplied by my x plus 3. Minus, now I'm going to look at my green function. So if I have 6 times 3, that gives me a positive 18, and that's going to get multiplied by an x minus a 3. And all of this is equal to a 7x squared plus 6x plus my 63. So if that's the case, I'm going to go ahead and distribute so that I have an 8x squared plus an 8 times 3 is going to give you a 24x. And I have a negative 18 that I'm going to distribute. So a negative 18x. and 18 times 3 is a positive 54. And all of this is equal to that 7x squared plus 6x plus 63. So now, combining like terms a little bit, I still have my 8x squared. And now I'm going to have my 24 and that negative 18, which is a positive 6, plus 54 is equal to that 7x squared plus my 6x plus 63. So now what I want to do is subtract everything. So minus 7x squared minus a 6x and minus 63. So everything on this side cancels. That's why you have a 0. And 8 minus 7 will give you a 1x squared. The positive 6x and the negative 6x cancels out, so that's nice. Now I have a 54 minus 63, which gives me a negative 9. Well, that is just a difference of squares. If I have x squared minus 9 is equal to 0, that factors as an x plus 3 and x minus 3 equal to 0. So if I set each one of those equal to 0, so x is equal to a negative 3, and x is equal to a positive 3. And you always want to make sure, does it contradict anything in my least common denominator? So remember, your LCD was 24, x plus 3, and an x minus a 3. So we want to check that. Well, let's see what happens when you plug in this x is equal to a negative 3. Well, if I plug in negative 3 here, I have a negative 3 plus 3, which is equal to 0. That's going to cancel out. So if I have a denominator as 0, that's no good. I have to throw that answer out. Now, let's take a look at x is equal to 3. Well, if I let x is equal to 3 here, I would have 3 minus 3, which is equal to 0. Well, that's not good either. So we did all of this work to find two possible solutions. X is equal to negative 3 and x is equal to negative 3. But when I plug it into that LCD, that least common denominator, I get a 0. And remember, a 0 in the denominator is undefined. Those tells us that these are bad answers whenever the denominator is equal to 0. So you're actually going to say no solution. There is no solution because the only two possible answers that I found gave me a 0 in the denominator when I plugged it back in. Therefore, there is no solution to number 4. I did all of that work to say, nope, nothing's going to work. Okay. Now, let's go ahead and look at number 5. So this one, it looks like I'm factoring. So let's just go ahead and factor. So let's start off with our first fraction here. So I have a 2. If I factor this out, I have 8, which is 4 and 2. So it'd be a positive 4 and a minus a 2. Minus, looking at our second fraction here, I have a 1, and let's factor that denominator. So multiply to 20 would be a 4 and a 5 if they're both positive to get a positive 9. And it's equal to our last purple fraction, which is a 4. And if I factor out my denominator, multiplies to 10 is 5 and 2. And if I want a positive 3, it would be a positive 5 and a negative 2. So now I have factored everything out as much as possible. So now I need to find my LCD. Well, it looks like my LCD definitely has an x plus 4. I also need an x minus a 2. And it also looks like I need an x plus 5. So let's see what's missing from each fraction. So for my green fraction, it looks like what is missing is an x plus 5. So I'm going to multiply top and bottom by an x plus 5. My blue fraction looks like it's missing an x minus a 2. So top and bottom gets multiplied by an x minus a 2. My purple fraction, it looks like an x plus 4 is missing. So top and bottom get multiplied by an x plus 4. Now I can just concentrate on my numerators. So I have a 2 times an x plus 5 minus my x minus my 2 equal to my 4x plus 4. So when I distribute and combine like terms, I will have 2x plus 10 minus my x plus 2 equal to a 4x plus 16. So to combine like terms, 2x and a negative x would be a 1x. If I have a positive 10 and a positive 2, I would have a positive 12. And that's equal to a 4x plus 16. So what I can do here is I'm going to subtract a 1x from both sides, so that a positive 12 is equal to a 3x plus 16. So I'm going to subtract 16 from both sides, so that 12 minus 16 gives me a negative 4. So x is going to equal to a fraction, and it's going to be a negative 4/3 as my fraction. And I know that that is a good answer because it does not give me a 0 when I plug it back into my least common denominator. So when I plug it into my LCD, none of my factors are going to give me 0. So that is going to be my answer. X is equal to a negative 4/3. And that is the end of this section. So if you guys have any questions, please feel free to email me, the Math Success Center, or our tutor. Thank you.